Hello everyone. So in this first video of a series about CCS, I will demonstrate how Seisnetics can be used to QC seismic data and then go for time-lapse analysis. And for this, we will work on the Sleipner dataset. So as you might know, there are quite a few seismic volumes for Sleipner available online. And so the one I'll be working with today are from the baseline acquired in 1994. And this one has 4 different reprocessings. I have one in 2001, 2007, 2008, and 2010. And for the time-lapse analysis, I will be using the last one from 2010 with a processing done in 2010. So of course, the first thing that might be interesting when you go into seismic analysis is basically to compare different seismic volumes. So with this in Seisnetics, we have a module called Seismic QC. And for instance, the idea here is I will try to compare maybe 2 seismic. So here you see that I have superimposed both. And if I move one, then, or one or the other, then basically one will go in front of the other. And you see clearly that I can identify already here the same reflectors, especially the one here in the middle around 900 milliseconds. So now what I can do basically is open the surfaces that were extracted using the automatic algorithm of Seisnetics. So I'm gonna open the geopopulation. So here is the first one for 2001 and the second one for 2008. So of course I can start by selecting, these surfaces. So I'm gonna click on this one and I'm gonna activate and click on this one and put this in 2D. So if I go, for instance, at the top, I have both surfaces. So I may just change the color. So here you see that I have both surfaces, so the same ones over both volume. Now the idea is if I would like to compare these volumes and find all the surfaces and see the differences between volumes, I can open the Seismic QC module, which is available in Seisnetics. And so I can give it a name. So for instance, I can call it comparison 0108. I'm going to have this. I'm going to take the first dataset 2001, second dataset 2008, and I will compute all the differences over the whole two-way time. And so it will come up with statistics. So on the top left here, you have the number of surfaces. So in red is for the first volume and in green, the second volume. And so you see that the volume from 2001 has more surfaces than the volume from 2008. And here I have the distribution and the size of surfaces. So the size in the x-axis and their position in the y-axis. So two-way time here. And so what I have also there is distribution. So the shift based on the geopopulation count, and the size ratio for these geopopulations. So I can compare basically and change the size. So you see that I have quite an inhomogeneous distribution around the mean here, 0. And here also something which is basically shifting to the right side. So the surfaces are bigger in one volume compared to the other. And so on this graph, you see the size ratio versus shift ratio. So we have quite an alignment on the size ratio around 0, but for the shift, you see that everything basically has been shifted downwards. And so what I can do now is Seisnetics has also automatically found the surfaces corresponding between both volumes. So if I take, for instance, this one, I can compute a few attributes and including also the waveform difference. So you see that's the waveform for this, for the surface in red is for the first volume and in green for the second volume. And of course, I can compute the shift ratio and the size difference ratio that will be added to the main menu. And then it's going to be possible for me just to display these differences. So here I took, for instance, this surface. And if I go on my volume, you see that indeed, once again, I will just try to change the color of one, but I'll put it in yellow, or even something more visible, blue. And so you see, indeed, I have found the same reflectors, so one in blue and one in brown. And so what I can do now is I can compare the surfaces. So I have one, and here's the second one. So this one, 2001, this one is 2008. And so you see that indeed I have very similar geometries, I would say, and fitness maps. Regarding the amplitude, I can compute the amplitude for both to see if there are differences. And as I said before, using this QC module, you can basically compute the differences of the waveforms. So for instance, if I go here, attributes, I can compute, for instance, in this case, all the differences between both. So I can compute and save the maps. And now they have appeared here. So that's, for instance, the difference between the base and the monitor. So you see some has been pushed slightly up, some down. The difference in amplitude between both volumes. Just change the scale a little bit. So something, some higher amplitude maybe on one compared to the others. The trace-to-trace correlation and the fitness difference between both. So that's basically where the main variability is when you compare the fitness maps and the waveforms for both volumes and reprocessings. So this is for the QC using Seisnetics, which will allow, of course, the interpreter to choose a seismic image, to go deeper into the interpretation, the comparison, then of course build the geological model, the static one, and then the dynamic simulation to compute different scenarios where the CO2 might go over time. So that's for the first part of the CCS videos, and this one is Seismic QC for the Sleipner datasets.